Hi there. Welcome to Xamarin University. My name is Mark Smith, and I'm going to give you a quick lightning lecture on geofencing in Android. So let's start by defining what we're talking about. A geofence is a defined region around a GPS location that can be registered with Android so that your application can receive notifications when the device enters or leaves that region. For example, let's say you're a service technician with a dozen house calls to make on a given day. We could use geofences to add support into our service management app that automatically sends a text message to the homeowner when you're 5 minutes away. Or suppose Disney World has a new app that they want to announce the presence of characters, but only to people within a certain proximity of the character, to limit the number of people that might show up. Or you could have a reminders app that prompted you to pick up the milk when you next visit the grocery store, giving you an alert when you pull into the parking lot. Or finally, perhaps a coupon retailer that notifies you when a great sale is happening right around the corner. Android has a built-in API to support this sort of logic. In fact, there's going to be two APIs we look at today, one included in Android itself and one that's part of the Google Play services. Now, this lightning lecture is actually an extension of Android 2.31, the locations lecture. And so I'm going to assume that you've already seen that content and that you're familiar with some of the APIs that we talk about. And so I'm going to limit this discussion specifically to geofencing and using those APIs, not about setting up the location management itself. The Location Manager in Android supports a basic form of geofencing through the Add Proximity Alert method. This takes a coordinate and a radius in meters where the area of interest is located. You can then specify an expiration timeout in milliseconds for how long this alert should be active. And finally, a pending intent to activate if the device moves into the radius circle defined by that point. The pending intent will identify the specific intent to launch when the proximity area is breached. You can use any valid intent type, but broadcast receivers are very common for this because they can be made local and run outside the bounds of an activity so that they don't affect the UI. You can add additional parameters to the bundle passed to the intent when registered, including data about the proximity alert, such as point of interest name or maybe a unique identifier. The identifier is particularly useful if you want to use the same broadcast receiver for multiple proximity alerts. To create a broadcast receiver, you create a class that derives from broadcast receiver and is decorated with a broadcast receiver attribute. You can set the exported flag to false so that it remains private to the application if you choose. Then you decorate it with an intent filter attribute passing the name identifier used when you registered the pending intent. We called this intent name on the previous slide. The onReceive override is called when the proximity area is entered or exited by the device. The intent will contain all of your data passed from the pending intent, as well as an additional Boolean flag with the key proximity entering, which is held in a constant on the Location Manager class. This will indicate whether the notification was sent because you entered the area or you exited it. One thing to be aware of with these notifications, they aren't very reliable on simulators. And on devices, you need to make sure that your area is large enough so that the device is in range for a reasonable amount of time, or it won't trigger the alert. This is a common issue when people are trying to debug this sort of code. They're using simulators or mocking their locations and moving through the area too quickly to be registered by the system. As with location services, Google Play extends the geofencing API with a more substantial implementation, and if you're willing to take a dependency on it, you can take advantage of this superior API. It works essentially the same way. You register your circular regions with the Geofence API, and it will invoke an intent when the geofence is crossed. The data used is identical to the Location Manager version, a coordinate and radius in meters, along with an optional expiration. Here you can see an example of the API. We use the exact same broadcast receiver, but the setup uses builder objects instead of a single method. In addition, you have a bit more control over the API. You can set the specific transition types to be notified about, when you enter, when you exit, or when you linger within the area. It also supports multiple geofences internally, unlike the Location Manager API, where we have to associate our own request ID in the bundle to distinguish them. Here, we must set a request ID which identifies this specific geofence request. The broadcast receiver can obtain data about the geofence crosses by getting the geofence event object which is stored in the past intent. This is specific to the Google Play implementation, and this contains the transition type, whether we entered or exited, as well as the triggering location and crossed fences. Notice that the crossed fences is actually an array because the event might involve multiple overlapping fences for a given location. You can also grab all of your custom data just as we did before. So let's quickly take a look at some of this. So here I am in Xamarin Studio, and I'm using the same solution that we used in Android 2.31, our Droid mapping application. But I've added quite a bit of code to this. Now, I'm not going to actually add any code to this project. This is actually a completed solution, and I'm just going to walk you through the pieces. It turns out that geofencing is actually quite complex and requires a lot of moving parts because of the broadcast receiver bits. And I also have another thing in here, which is a mock location provider. Now, when you use geofences, obviously it's related to things that are moving, and so we would have to carry our device, and it would be very difficult to do that and try to record a session at the same time. And so what I'm going to do is actually tell the device that we're in a known location and have it move as I tap on the device itself, and tell the location manager that my actual location is changing. So we do that through a location provider, and I'll show you that code here in a moment. But let me go ahead and open up MainActivity where all of the real code actually happens. And so if I go here to the top, you can see that this is just the same MainActivity that we were using before. It's got all the Google Play code in it. We're using the MapReady callback. We're using the location listener interfaces. All of this was covered in Android 2.30 and Android 2.31. The two new pieces that I have in here are a new instance field to provide my mock location provider and my geofence trigger receiver. So this is the broadcast receiver code that's actually going to be notified when we enter or exit our geofence. We have to register that broadcast receiver, so I'm doing that in my onCreate override right here, where we create an intent filter, we give it the intent name, and then we call register receiver. This is simply a method that's built into Android that allows us to register both the broadcast receiver that we've created as well as the filter that we're using to represent it. And then I'm finding my map fragment, setting up Google Play, and you can see I've added in some new pieces into the UI that you'll see in a second when we run the app. If you scroll down a little bit, in my onMapReady, I'm adding in a map click handler here. This is what we're going to use to change our current location or to simulate the location. And I'm also setting up my mock location provider right here once my location services are prepared. We're going to set our initial location to be the Xamarin headquarters, and we're going to go ahead and set up location monitoring. If we scroll down a little bit further, you can see in my map on click, I'm just calling my mock provider and calling a method called setLocation. So let me show you what that looks like. If we look at the location provider, you can see it's just a class. It has a constructor that I've created here, and it actually supports both Location Manager as well as the Google Play location services. And so here we're using the Location Manager, and we're finding it from the context that we pass into the mock location provider. And you can see I'm adding the test provider and then setting the test provider to be enabled. Then, when I call setLocation, I create my location object itself, and it's got a little bit of odd code here with a try-catch because some versions of Android actually require that a certain field is flipped on the location object, but it's not public, and so we have to use a little bit of reflection to be able to set that. And so you can kind of see that we're doing this with a little bit of Java reflection. Then if we have the Google API services turned on, we then have an API client, and we're going to use the fused API and set our mock location. And then we'll also tell the location manager to set our test provider location as well. And so this is a standalone class that you could use in your own testing if you wanted to. It's very, very simple. You simply call the constructor here, you pass in your API client and your context, and then you just call the setLocation method anytime you would like the location to change. And then when you're finished, you call the shutdown method here that will remove itself from the system. Now, one thing to be aware of, before you can use this class, you have to have the access mock location privilege set in your app, and your device has to enable the option in the developer settings. And so there's a setting on the device that allows you to mock the device's location. That's true in the simulator as well. And so if you're using a simulator or a physical device, like what I'll be doing here, you're going to have to set that flag in the developer settings. Okay, enough about mock location. So anytime we tap on the map, we're going to set our location. That will simulate it on the device itself. Then what we're going to do is anytime that we tap on the button, so let me scroll back up here, notice our add button. Anytime we tap on the button, we're going to take this location text that we type in. We're defaulting it to Fisherman's Wharf because we're going to start in San Francisco. And then we're going to call this method called setupGeofence. This is a method that I've created, and you can see that what it does first is go and get the coordinate for that location. So we're using the code that we discovered in Android 231 to take a location and find a lat long for that location using Google services. If I get a valid coordinate out of that, I'm going to go ahead and place a circle around the midpoint of this with a 50 radius, and then we're going to add our proximity alert using that coordinate. Now, the add proximity alert method is another little method that's in this class, and it's got a couple of things in it. First of all, the method takes the lat long coordinate itself. Then it takes a point of interest name, and it takes two actions. One to call when we enter that geofence, one to call when we exit the geofence. Now, this is just my construct here. You could do this logic however you like. I did it this way for simplicity purposes so that you can see how it's all put together. It's not necessarily the best way or even the only way. You could do it in a variety of different ways. But what we're going to do here first is take our receiver that we created and call this register actions. I'll get to that in just a moment. But what it does is it allows us to pass in these two functions or two actions for entering and exiting, because the receiver is what's going to run that logic. So when we enter into the geofence, the receiver will execute our enter work delegate. When we exit out of the geofence, the receiver will run our exit work delegate. We then create the receiver itself. We do that by creating a new bundle. We add in the point of interest name. We add in a unique identifier. We create the intent using that exact same intent name that we registered earlier. And then we add all this into we add all of our details into the intent, so the extras into it. And then we call pending intent get broadcast. This is what lets us find the registered broadcast receiver. Once we have that, then we're going to register the geofence itself. So all of that was just setup code. So here you can see we're testing to say, do we have a Google API client? In other words, is Google Play Services installed, and is it available on the device? If so, we're going to use the Google Play Services version where we create a new geofence builder. We set the transition type to be enter and exit. We set the region to be our lat long coordinate with a 50-meter radius around it. We set our request ID, which is just a string that uniquely identifies this particular geofence. We set our expiration duration to be it never expires, and so we just want it to be continually there until we tell it to go away. And then we build the geofence request. To create the geofence request, we take a geofence requesting builder. We add the geofence to it. You can add multiples if you like. And then again, we call build. And then finally, we go to the Geofencing API on the location services class and say, add this geofence. And so the set of geofences that we create with this request will then be added into the API, and the system will call our broadcast receiver whenever we actually enter or exit the perimeter of that location. If we don't have the Google API services, then we're going to use the location manager. And so this is the same technique that we used in Android 231, where we fall back gracefully to the older APIs. We go find our location manager from the context, and we call the add proximity alert, passing in the point, passing in our radius, telling it the timeout, which is -1 here to indicate that it never expires, and giving it that same pending intent. We then add the geofence request, the pending intent, to a dictionary that we're going to hold on to using this request code. And the purpose of this dictionary is so that we can remove the intent later. And so you can see I've added another little bit of code in here called remove proximity alert that takes the request ID and it takes a circle that we're going to put onto the map. And so if you remember, we created a circle to denote that geofence. We did that earlier in the setup method. So we're going to go find that pending intent from our active geofences dictionary. If we have an API client, we remove it from Google Play Services, otherwise we remove it from the location manager. We then get rid of the dictionary entry. We unregistered the actions from the receiver, so this is our two delegates, the enter action and exit action. We're going to go ahead and get rid of both of those, and then we're going to wait 1 second using task.delay. So this is just returns a task that blocks for 1 second, and then we'll come back on the same thread and we'll go ahead and remove the circle. So if you're not familiar with the Shapes API, putting a circle onto the map and then removing that circle, you can go watch the other lightning lecture that's related to location services and mapping on dealing with shapes, where we draw out a route based on the Google Directions API. And then you can see here's our location change. We're going to go ahead and get our point, and then we'll just create another circle here to show our current location. So that's just simply to deal with the current location. And that's all the code. So let me show you the broadcast receiver where we actually receive these events. I told you there was a lot of moving pieces to this. So here's our geofence trigger receiver. It derives from broadcast receiver, and it has two attributes on it. Broadcast receiver attribute with an exported equal false. That just says that it's local to this process. Only activities in this process will be able to interact with this broadcast receiver. If you don't set exported false, then it means that outside processes could send or deal with pending intents to actually talk to this broadcast receiver. We then have our intent filter. Notice we use exactly the same name here to register the intent filter. So the same thing that we used when we registered it, the same thing that we used when we created the pending intent. And that's just this constant name right here. All right, so this is just a best practice or a guideline to use like something similar to a package ID, like what we would do when we actually create our package ID, so com.Xamarin.Android mapping.geofence, but it can be any string that you like here. It's just the name that we're going to use to represent this intent. Here's our register actions method. This is what we call to pass in the interaction exit action. We're just holding that in a dictionary, and we're assigning it to the key, this request ID that we used. The unregister actions just removes those two elements from the dictionary. And then here's the core of the work. We have this on receive override. So this is a virtual method. It's called when the intent is actually run. And so notice we get past our context and we get past our intent information. So this is the data copied out of the pending intent that was used when we registered this particular broadcast receiver for the geofence. So the first thing we're going to do is go and get the Boolean extra location manager key proximity entering. The default that we're going to use here is going to be false. And so when this comes in, we'll either get a true or false out of this get Boolean extra. And typically, if we're using Google API services, this key will not be present in the intent. It would only be present if we're using the location manager. And so this will often be false because more often than not, we'll likely have Google Play Services available. We then use the geofencing event.from intent, passing in the intent. So this would only be used if we were using Google Play Services. So this is Location Manager, then this is Google Play Services, and we're just going to set that same entering flag. So it will either get set from this, from Location Manager, or it will get set from this if we're doing Google Play. We'll go get our crossed fences and we'll get our actual triggering location, and we'll just output it to the log. So this is just a little bit of code to say, hey, we used Google Play Services to find this. Here's the actual point that we entered, and then we crossed some number of fences. Then we're going to go through some common shared code here that would be used regardless of which approach that we took. We're going to go ahead and get our extras, get the point of interest name, get the ID. This is the request ID. And then we're going to go try to find the actions. And so if we registered any actions for enter or exit, we'll go ahead and pick those up. If we're entering, we'll log that, and then we'll go ahead and run the action. And if we're exiting, we'll log that, and we'll again run the action. And so whatever we were told to do as a result of entering into the geofence, we'll just execute that. When we exit the geofence, we'll use whatever action we were told to do on the exit and run that. Okay, so let's see what this actually does. So here we are in the app. This is a Nexus device that I'm reflecting back onto my screen. And I'm going to go ahead and dismiss the keyboard and move my position over just slightly. And you'll see when I tap here, I can actually get my current location in there. Remember, that's just the circle that we're drawing into this. Now, my goal is to go ahead and add a geofence. And so I'm going to tap the Add Geofence button, and you can see that we draw our circle, and it gives us our geofence perimeter. And I'm going to go ahead and tap on the screen in order to move our current location closer to the geofence. And so remember that this API is either using the location services or it's using the Google Play services. In this case, it's Google Play. And as I enter into the circle, you can see that when I break that perimeter, we execute our interaction, which is to color the circle green. And so that's the interaction being run by the broadcast receiver. And then as I exit that perimeter, we color the circle red, and then 1 second later we remove it. And so remember, that was the remove proximity logic that we walked through. So let's try this again by adding the geofence back. And we could, of course, use any location we want. And what I want to do is go ahead and, again, change my location so that I cross that threshold. Now, you have to be a little bit careful here. Notice that I jumped into the middle of the circle and it didn't trigger the broadcast receiver. And that's because the API is very sensitive. We have to actually cross that perimeter threshold. If I jump right into the middle, it's not going to detect that. And this isn't an issue typically with a real device because you can't really, well, first of all, because we get continuous updates from the location services, but it would be very difficult to just jump that far without some sort of Star Trek teleport device. And so generally speaking, on a physical device, you won't have that issue. It's only when we're simulating it and we're able to kind of jump our location from one place to another instantaneously that the API would have trouble keeping up with us. And so let's move outside the circle, and we didn't quite catch it that time, so let me move back in and see if I can cross that circle and catch the perimeter so that the API catches it. There it goes. And then, of course, 1 second later, our circle disappears. So that's the geofencing API. I hope this lightning lecture has been helpful in showing you how to use some of the geofencing APIs in Android. You can grab the sample code and all the slides from the materials link associated with this video. Thank you very much, and have a great day.